I'm sure you've heard the news. It seems like everyone's building gadgets now. From smart home devices to custom keyboards, the maker movement is booming. And at the heart of every one of these electronic wonders is a printed circuit board, or PCB. But how do those intricate green boards, the silent heroes of our digital world, actually get made? It might look complex, but it's a logical process that turns a simple idea into a functioning piece of hardware. Stay with me, and I'll break it down for you, step by step. It all begins with defining your requirements. Before you touch any software, you start with the core idea. What will this device do? You'll want to create a detailed list of its functions. Alongside that, consider the constraints. How big can it be? What's the budget? How will it be powered? These initial decisions will guide every choice you make down the line. Next up is part selection. Based on your requirements, you'll choose the specific components, the microcontrollers, sensors, resistors, and capacitors that will bring your functions to life. This list is called a bill of materials, or BOM. It's crucial to check not just the price, but also the availability and the physical footprint of each part. With your parts chosen, it's time to draw the schematic. This isn't a physical layout, it's a logical diagram, like an electrical roadmap. Using electronic design automation, or EDA software, you place symbols for each component and draw lines, called nets, to show how they connect electrically. Clear labels are your best friend here, making the circuit's purpose easy to understand. Now we think in 3 dimensions. You need to define the PCB stack-up. A simple board might have just 2 layers of copper, one on the top and one on the bottom. But more complex designs can have 4, 6, or even dozens of layers, sandwiching power and ground planes between signal layers. This decision impacts everything from signal integrity to manufacturing cost. Step 5 is the PCB layout, where your project starts to look like a real circuit board. This is a critical phase where you translate the schematic into a physical arrangement. You'll place the digital footprints of your components onto the board, carefully considering the path signals will take. Good placement minimizes electrical noise, manages heat, and makes the board easier to assemble. Once the parts are placed, you perform the routing. This is the process of drawing the physical copper connections, or traces, between the components. You'll determine the width of each trace based on the current it needs to carry and use vias to connect traces between different layers of the board. This is where your electrical roadmap becomes a physical highway system. Before sending anything off to be made, you must run your checks. Your software has a design rule check, or DRC. This powerful tool automatically verifies that your layout doesn't violate any manufacturing constraints, like traces being too close together or too thin. It's your first line of defense against costly mistakes. But don't rely on software alone. The next step is a peer review. A fresh pair of eyes can spot logical errors or potential improvements that you might have missed after staring at the screen for hours. It's also a great practice to print your design at a 1-to-1 scale to double-check component footprints. With your design checked and double-checked, you're ready for fabrication. You'll export your layout into a set of files called Gerbers and send them to a PCB manufacturer. They'll use these files to etch your design onto copper-clad laminate, creating your very first prototype. Once the bare board arrives, it's time for assembly and bring up. This is where you solder all your components onto the board. The first power on is always a tense moment, often called a smoke test. You'll want to use a current-limited power supply just in case there's a short circuit. Finally, you test, fix, and repeat. Using tools like a multimeter and an oscilloscope, you'll verify that every part of the circuit works as intended. Your first prototype will almost never be perfect. You'll find bugs, make fixes, and update your design. This iterative cycle of testing and refinement is what leads to a robust, reliable final product. Feeling ready to start your own project? It helps to have a guide. Want a starter checklist to walk you through the design process for your first PCB? Hit that like button and subscribe to the channel, and we'll share a free one to help you get started.